So hi everyone. Um, anyway, I just uploaded a 3 minutes video to my LinkedIn, so which explained the concept under 3 minutes. Um, in more easy for me to explain because I'm from Hungary, so this is a technical word. It's sometimes really challenging for me in speaking English. But thanks for the opportunity. My name is Peter Varga, a Web3 and XR developer. And in the last 15 years, I have experienced a lot of knowledge in web development. I combine a deep understanding of emerging technologies with passion for creating immersive learning experiences. The current trend shows that the web and all digital media content are evolving into the 3D space around us. Therefore, I'm preparing my PhD proposal in UK to focus on the role of spatial computing, especially in Education 5.0. Early this year, I was involved in a pilot research at University of West London, where I developed a customizable framework for web-based VR sessions. So during my master degree back in 2018, I gained an extensive knowledge in human and computer interaction using EEG devices and 3D visualization. And since 2020, I've been deeply involved in Web3 and XR development field, creating several AR and VR experiences using my favorite framework, which is the WebXR, shortly VR on the web. I'm really passionate about making web more immersive and accessible through the generative AI and extended reality. And my aim with this presentation is to connect with academic professionals and supervisors who may be interested in my research field. Let's see the next slides. Yeah, that was my slide. So let's jump over to the next one. And so before I start my presentation, I trying to provide what I'm going to cover in my proposal. First, I will describe some of the problems, then introduce my current VR trends. I believe it is crucial to understand the current availability of the technology, both hardware and software perspective. In the second part of the presentation, we'll overview the possible data collection tool for conducting my research. And the end of the slides, I will a brief demo of the VR classroom as a solution. And the next one. So let's define first the problem. What is the problem? Based on my literature review and my personal experience, around 80% of the current university teachers are using boring PowerPoint slides and presentation slides, and the style is not appreciated. The text and the verbal explanation are not just boring, but sometimes confusing for the students. This is the redundancy principles that state the learners can learn better with animated video and narration. But the visual text information presented at the same time with the verbal information sometimes becomes confusing, and this is called redundant material. This is what we call overload of information, especially then when someone not a native speaker. Slides often contain too much text or too small, overwhelming students with repetitive information. This can lead into a cognitive overload where the students struggle to process and retain the material what is presented. And the slides typically not facilitate introduction and interaction between students and the teacher. The kind of one-way communication, like we call it, students not able to ask any question during discussion about ideas. The activity is like as a passive learning method. The fact that the PowerPoint presentation only supports that kind of passive learning style, which in 2024 is not accepted. So I more prefer when the students are more involved in the subject and they can collaborate with others during the lecture material. So the critical thinking these days is really crucial to get a better, deeper and understanding. Lastly, what I saw mainly, slideshow are poorly designed. I know not everyone a designer, especially in the education sector, but sometimes the small are too small or not well directed, so the UI design needs to little bit improved. And the color and images are not really well designed again. So this can be distract and confuse students, reducing the effectiveness of the presentation. And all of these aspects can result in a lack of focus, concentration during the traditional lectures. Therefore, is my opinion, I see the huge potential in VR or XR-based education due to the engaging and interactive 3D content. Additionally, VR classrooms support collaborative sessions. So basically, it can be a part of the distance learning. Doesn't matter where you are, the people can join to you and create a virtual event. And the next slide here, let's see. I want to a little bit talk about, but not deeply about technology because I'm basically a web developer. So let's delve into the tech and first define spatial computing, which is entirely new term, which mainly many people know about spatial computing as virtual reality. However, in last year, 2023, the key trend in spatial computing have emerged thanks to the hardware manufacturers such as Meta and Apple. The VR adoption is becoming more popular among IT enterprises for training and virtual events, and also 3D visualization using digital twins. Spatial computing, as many as know, Apple introduced last year. Uh, People are a little bit confusing because XR as extended reality is kind of the umbrella definition of the spatial computing. So it is a kind of next iteration of the internet by creating a three-dimensional web around us. With this technology, um, with this technology around can be more interactive canvas. Doesn't matter where we are. We don't have to use a monitor, mobile phone, laptops. The internet and the web accessible from anywhere for everyone. Every gesture, every glance, blink and pinch is really important to communicate between the computer and the human. This is a new kind of digital interaction we have to learn, and it's maybe take 10, 15 years to understand what the next stage of the internet and the interaction. I believe the next 5 years, not just 10, but in the next 5 years, the two-dimensional traditional monitors we will left behind, and the new concept opening, we call it metaverse. And this is really new because just think about you have to just wear a glass, not as heavy. Currently, we have here behind me, I'm not sure it's visible, as a VR headset. And we're trying to create something which is more lightweight, more suitable, more comfortable for everyone. So the next slide here, which is more focused area about digital twins. As I mentioned before, digital twins play a crucial role in training and education. To keep it simple, digital twin is just a virtual representation of the object or system design accurately reflect the physical world. It's a copy of our physical world basically. Using digital twins in VR education offers an enhanced and immersive learning experience in a cost-effective way. If we are not calculating the cost of the VR headset, of course, because currently many universities are struggling to get the basic 5, 10, 15 VR headset in stock. So this immersion helps learners to engage more deeply with the subject, making complex concepts easier to understand and retain. For example, we just think about engineering students can visually inspect a turbine, zooming in and out, walking around, different components can build, like compressor, chamber, or the turbine blades. They can even remove and rebuild the entire object virtually. So this is what we call learning by doing in a virtual place. Another example for medical students is my favorite, the participating in a surgical procedures on a digital twin of the human body, providing a realistic but risk-free environment and hands-on learning. It's really popular in these days, I know, at UWL also. And the next slide here, to turn a little bit into my research focus. The research has two main parts. First, I doing a development circle as a web developer to build a customizable VR classroom with a meaningful 3D content. And the second part, to I want to, of course, measure the efficiency of this VR classroom and compare it with the traditional method by collecting real-time brain data. We know that the integration of VR in educational setting has a promising potential in enhancing learning outcomes. However, quantifying the effectiveness of the VR-based learning remain a challenge. Because currently, it's my personal experience, we're just collecting surveys, questionnaires. This is so subjective. We need more objective data like the electroencephalography, EEG data is never live. So my proposal aims to introduce an EEG headset combined with the VR to measure students' concentration and focus, thereby determining the efficiency of the learning outcomes. So the current challenge for both developers and educators is to build a VR space with high quality content, especially which is on the subject for the education, and effectively utilize this 3D space and provides an additional value to the students. And this can be really complex because we need to rethink and redefine the 3D space, which is not the PowerPoint slides or a 2D monitor screen. So when we are creating educational content in a three-dimensional space, it's really new for everyone, not just for educators. And as a student, begin to learn about concept relies when the size and the scale in the science. So the VR can really help to understand concept, which is really huge or maybe too small. And this is really important because if the microbiology or planetary system, we don't have any other option to explain. So the VR can be a really promising way. So recently I have built a classroom framework using this previously mentioned WebXR, where the artificial intelligence concept really easily explained and really easily understandable. So how we want to really explain for students the deep learning, the diffusion model or blockchain technology. It's really difficult and mass concept is we need definitely the 3D space and the time to explain this definition. So let's see the next slides, which more about the aims and the objectives. So as I mentioned here, with the proposed research, I trying to investigate how to build better web-based VR classroom with high quality content, which is really improve the learning efficiency. During my research, we will measure two really important things, effect, which is the focus and the concentration. The focus is just a certain time and the concentration needs to be more than 5 minutes. So my algorithm, which is the high beta, needs to be constant and high level during a specific task. So if some of the students are struggling to understand the concept or maybe distracted from any external noise or not watching the material, so I can measure these spike artifacts and I can analyze later using my AG software. So very important to understand, we're not just measuring the efficiency in the VR classroom, I'm trying to measure this efficiency in a traditional method. Then I can compare both and we can say which one is better. Of course, there are certain scenarios when the traditional method is good enough, but there are some concepts, like I mentioned, the planetary system or microbiology, which are really useful if we have a VR headset. So my main objective of the research to develop at least 6 VR classrooms featuring diverse 3D subjects. And each piece of 3D content will be supervised by academic experts in their respective fields to ensure the accuracy and the clarity. Because I'm not expert everywhere, of course, so I need some of support. So that's why I'm here today. If I can find academic people who can collaborate with me at the UWL later to build really good customizable web-based VR classroom, and I can provide for free because this is a WebXR, so it's an open community. And let's see the VR setup. Sorry again, it's more technical again, but it's really good to understand because this is the future basically. In the last 4 months at UWL, I used the test the framework with a standalone VR headset, which is the Meta Quest 2, Quest 3, and also using Pico 4, which connected to the Wi-Fi 6 network. Our test environment is based on WebXR, and which is 100% on the web. Therefore, the stable Wi-Fi connection is really crucial, because if we had just maybe 10, 15 megabit per internet secondum, bandwidth is not enough, unfortunately, to support the high quality 3D content. So I wouldn't want to go deeply into this WebXR because it's more about the development side. So what I try to explain, the minimum requirement to run the platform is a VR headset like Quest 3, 150 megabit per secondum of Wi-Fi connection, and we need a low latency. So when we are communicating with each other by voice, just think about, I implemented into VR a Zoom API. So the student can communicate by voice and also collaborate visually, like in a physical world. So the next one, here you can see hopefully 2 video content, which is my previously developed stage. One is the single user mode and the multi-user mode. So the special design is to remove cognitive overload. So everything is linear. So student can repeat all media content until she or he can understand the subject fully. In this way, by following the redundancy principle, educator can keep any educator and any teacher, because it's really simple to add 3D content to this platform, can create effective and engaging presentation that support better learning outcomes and reducing the unnecessary cognitive load. The single user mode, what you can see left-hand side, is a single room accommodation when you are at home. So the environment is simple but interactive. I added a YouTube video screen, a mobile phone, a 3D object, and the presentation board. So it's like when you are at home and you're trying to learn a new subject, you have this space. And also in the future, I'm trying to add a generative AI assistant, like a ChatGPT. When you have any question, you can ask them. Of course, as in a previous presentation, that was true. Sometimes we have some hallucination and the ChatGPT is lying. So never trust them. Trust the ChatGPT currently. So the multi-user mode is a little bit more complex. It's like a collaborative office with a TV screen and 3D objects, which can easily replaceable anytime. The user can choose the name and the avatar, so we can identify each other easily during the session. And please note, the first participant need to host, and then other can join, like as these Microsoft Teams or a Zoom meeting, working in similar way. And with the presentation, I'm sharing the link so everyone can try out without any VR headset, because it's running on mobile phone and any laptop as well. So back to my original field and focus, why I'm using EEG. As I mentioned, I have done my master degree, so I have some of the knowledge about how we read data from the brain. And the question really occurred, why this kind of EEG and why news? Because many people said this ankylograph is not a clinical graded sensor. But I searched on the net, and many scientific people already using Muse EEG. And it's really cool because it provides real-time feedback and is really objective to read the data in real time. Therefore, is again allowing better understanding how efficiency the VR learning method. So in the next slide here, how I use it basically. And the proposed research aims to investigate the impact of the VR classroom on students' learning efficiency by analyzing this data. I just focusing on the beta. Beta is represent the focus and the concentration. So the EEG as filtered before, and the methodology is like really simple. I'm planning to collect 10 participants, 10 students from the university, and we'll be asked them to divide into two groups. The VR classroom, which is the control, and the other one is a traditional classroom settings. So then we can later compare which one is better. We give you same material, same video content. Of course, in the traditional method, we're gonna print out the A4 pages. In the digital side, we just hand out a JPEG photo that they can interact with. I'm currently using a Quest 3 and the Pico 4 headset, which is really low cost device, but it's more than enough for this kind of research. And I'm using my previously purchased EEG headset, which is called Muse. Muse has 4 sensors. Also, I can show you. Here we are. It's really easy to fit. And both together is really comfortable. The duration of the session is around 10 minutes. And we want to extend later because we want to see if the 10 minutes is enough to accurately focus on a certain task. If yes, we want to extend this duration later. So as part of my research, I'm looking my partners because it's not easy to bring the VR technology or any kind of technology into the educational sector. So I trying to get some feedback from others who in the academic field, because I trying to move in as a PhD student in the next year. So my subject is both and high education and university level to see how the people react, and I'm happy to customize any learning materials. If you have any idea or your community have any request, I'm happy to deliver that until November. So see how this research can go, because at UWL, we have a control group, but hopefully I can find others. Doesn't need to use VR headset at the moment, just to see how this digital content is interactable using mobile phone or a laptop. And I think that's it for today. Here is the live session. If you're scanning the QR code, you can bring using your simple mobile phone, and you can walk around this environment. But if you have any VR headset at home or at your school, you can try out. It's available at the nftech/xr domain. You don't have to install anything. You don't have to log in. You don't have to nothing, because this is an open source platform. So if anyone interested in generative AI or blockchain technology, neuroscience, or Internet of Things, or maybe high school virtual travel, museum, microbiology, or planetary system, I can add that kind of content, and hopefully your student can try out and give a feedback. It's really appreciated if can help me out. Thank you very much. And looking forward to build my team to achieve the next level of education, because this web VR is a new field and the spatial computing. So I'm also want to stay with you to find some people who are interested in this research area. Thank you very much.